Hello, fifth grade mathematicians. This is a review lesson. We covered this lesson before the holiday break, and I wanted to do a couple of videos over the holiday so that you can review before our unit test. So the key ideas are listed on this first page. These are things that you learn to do in lesson 3.6. You learn to calculate rates. You learn to use a formula to complete a table and analyze the results, the function. You learn to plot data from your table, and then you learn to construct a graph from your data and interpret the shape. So one of the formulas that we used in this lesson was a formula for calculating the distance that an object falls in a certain amount of time. So if we were to drop a golf ball, we wanted to measure how far it fell over a certain amount of time, we would use the formula distance, which is represented by d, equals 16 times t times t, t representing time, or we could say distance equals 16 times t to the second power, or t squared. So for example, if an item fell for 1 second, at the end of that second, the formula would be 16 times 1 times 1, or 16. The object would have fallen 16 feet after 1 second. After 2 seconds, the distance would be 16 times 2 times 2, 16 times 2 to the second power, which is 4. 16 times 4 is 64. So after 2 seconds, the object would have fallen 64 feet. After 3 seconds, 16 times 3 to the second power, which would be 144 feet. So we could complete a table where we had the distance that we were measuring and the time. And then if we graph the data from that tablet, or excuse me, from that table, what we would find is that our graph would be a curved line, different than what we've seen in earlier chapters. And that curved line would show that the distance the object falls during 1 second becomes greater and greater the longer the object travels. So it's going to show a greater and greater increase as the object is falling. Now, if I look at another formula, I'm going to get a different kind of line. And that's why we were looking at graphing and interpreting the kind of line we got. So we have a formula for measuring the speed in feet an object travels over time. We use the formula S for speed equals 32 times t. And again, t represents elapsed time. So we can measure the speed that an object is falling, not the distance it's fallen. That was our previous formula that told us the distance it traveled over time, and that distance increased as the time increased, and we got a curved line. In this case, we're measuring the speed an object travels over time. And if we completed a table of information with this data and we graphed it, we would see that there was a constant increase, or excuse me, we would see that there was a constant increase in speed per unit of time. All right, so the increase in speed during each second was constant. And we would end up with a straight line because we have the same rate of change over the amount of time that's passed. So in the previous formula, distance equals 16 times t squared. We got a curved line because that distance got greater and greater as time passed. In this formula, speed equals 13 times t, where t is time. We have a constant increase in speed. And when we have a constant change over time, we end up with a straight line. The other thing we learned to do in this lesson was compare unit prices to determine the best buy. And we find this by dividing the total cost of an item by the number of units. So when we go to the grocery store, we probably think about this most often. You'll see that bananas are so much per pound. And you'll see on the shelves they'll have the item with its total cost and then the price per unit. And that unit could be by ounce or by pound. When we pay at the gas station, it's per gallon. So here's a situation that I've described here, right here. We look at shampoo and we're trying to decide which is our better buy. A 16-ounce bottle that costs $8.49 or a 12-ounce bottle that costs $6.49, which would be the better buy. And if we divide the total price, $8.49 by 16 ounces, we get the price per ounce, and we find out that it would be 53 cents per ounce. If we do the same for the 12-ounce bottle, $6.49 for 12 ounces, and we divide, we find that the price per ounce is 54 cents. So if we wanted to save a penny per ounce, we would be buying the 16-ounce bottle. The store helps us out by listing very often the unit price. So again, if we go back to our very first slide, key ideas in lesson 3.6, calculating rates, using formulas to complete tables, plotting data from our tables, and then constructing the graph from that data and interpreting the shape. We might have a curved line, we might have a straight line, a curved line showing increase over time, a straight line showing a constant change. So remember to think mathematically because math counts.